Oink. Oh, hi everybody! Welcome back for another amazing geometry video! Woohoo! Yeah! Today we are going to be learning how to find the surface area of any pyramid. No matter if it's a triangular pyramid, a square pyramid, a rectangular pyramid, you name it. We're going to find the surface area of all the pyramids today. Well, not all the pyramids, but you know what I'm talking about, right? Just most of the pyramids in the pyramid family of shapes. You guys remember what this is, right? This is an equilateral triangular pyramid net because it's flattened out and all of the faces of the net are equilateral. But can I tell you that there is another specific name for this kind of net? Yes, an equilateral triangular pyramid could also be known as a tetrahedron. A tetra what? A tetrahedron. It has 4 triangular faces. That's why it is known as a tetrahedron, because tetra means 4. And what does hedron mean? I don't really know. But tetrahedrons are classified as triangular pyramids. One of the only main differences between tetrahedrons and triangular pyramids is that tetrahedrons tend to have all faces as equilateral triangles, while triangular pyramids don't need to have equilateral triangles as all their faces. But a tetrahedron could also be irregular, as in which case all the faces are but are not completely accurately known as scalene triangles. So we're going to look at tetrahedrons today. Then after that, we're going to find the surface area of all of these pyramids. Not just one pyramid, all the pyramids, except for the cone today. But we are going to find the surface area of a cone, just not in this video, so no worries. But just to recap your memory, a cone is a special kind of pyramid with a circular base and a bent lateral face that could either be a bent triangle or even a bent semicircle, as we briefly remembered. So, let's look at this new shape, a tetrahedron. That word tetrahedron, it might confuse you a little bit, but finding the surface area of a tetrahedron, although very complicated, could really be very simple, because it only requires one measurement, which is A, the edge, but it's not the easiest surface area formula to follow, because the cube has the easiest surface area formula of all the prisms. But for the pyramid, we say that the tetrahedron has the easiest surface area formula, because the surface area of a cone is much more complicated. But we're going to talk about that in another video, so no worries. So you're probably wondering what a tetrahedron is. Let me tell you about this new and special kind of shape. And if you can remember, this is not really a new shape, because we just looked at a triangular pyramid net where all the faces are equilateral. A tetrahedron has all the faces equilateral triangles. So guess what? This is also a tetrahedron. And this is a tetrahedron net. So I'm not saying I'm wrong. It could be an equilateral triangular pyramid net, but it's also known as a tetrahedron. Yes. The tetrahedron, although very complicated to follow, is actually the simplest of all polyhedra, or the simplest of all the 3D polyhedra. So, yeah, it's the simplest polyhedron to remember, the triangular pyramid, or tetrahedron. So, yeah, the only main difference between the two is whether or not the faces are equilateral. So, let's look at how to find the surface area of a regular tetrahedron. In a regular tetrahedron, all the faces are equilateral triangles, with the base as an equilateral triangle, and 3 more lateral equilateral triangles. In other words, these are simply the lateral faces, and that is the base. Because if you look here, this appears to be one large triangle. And this triangle, the white one, appears to inscribe perfectly inside the red triangle, which splits it into 3 identical triangles. So, this is a tetrahedron net. Very interesting. Looks like we learned a new shape. Well, not a new shape. They are the same shape, just with different names. but they could sometimes be different too. It's very complicated, but it's the simplest of all polyhedra, so don't worry about that. Let's figure out how to find the surface area of a regular tetrahedron whose faces are all equilateral triangles. The surface area is the square root of 3a squared. Oh, kind of tricky, but I'll take it. Yes. So basically, for a tetrahedron, we just have to look at one edge and then square it and then multiply that by the square root of 3 because we're squaring the square root of 3. So, wait, no. We're trying to find the square root of 3 and then we're multiplying that by a times a, or a squared. So, let's look at the tetrahedron net. What is the edge? Is it 20 centimeters? That's right! This measures 20 centimeters. The height of one of the lateral faces is 17 centimeters. We know how to find the area of a triangle, half BH. But, in order to find the area of a regular tetrahedron, or excuse me, the surface area, we only need one measurement, which is the edge. So, the edge, you're right, is 20 centimeters. Let's substitute 20 in, and then we're done. We're good to go. 20. Oh my goodness. We get an approximation of around 692.82032. So yeah, it's simply just 692.82. A lot of times, the surface area equations will have to ask you to round your answer to 2 decimal places. This is 2 decimal places, so you have to round your answer to the nearest 2 decimal places because the exact answer may be very long and very precise and complicated. So rounding your answer to the nearest 2 decimal places could really help you better understand the surface area of any shape, so of any 3D shape. So the surface area is 692.82, because if we look here, 20 centimeters is the edge. And if we look here, A is the edge, and this matches up the base. And all the sides have to be equal, so guess what? This is 20, this is 20, this is 20, 20, 20, 20, everything is 20, except for the heights. Be careful. The heights are 17 because all of them are equilateral triangles, meaning that the heights must also be the same. So the heights of all the equilateral triangles in this case are 17 centimeters. But the edges are all 20 centimeters. So the surface area of the tetrahedron would be 692.82. But finding the surface area of a net is quite different because you don't do it the same exact way. You just have to lay it out, find the surface area, find the area of one of the triangles, and then multiply that by 4 because there are 4 triangles. So let's see. We know how to find the area of an equilateral triangle, right? Half times BH, pretty much any triangle really. Half of 17 times 20 is 170 because 17 times 20 is 340, and half of that is 170. And if we multiply that by 4, we should get an answer that is close to this, but is not actually this answer. We get a different answer because we're not finding the surface area of the actual pyramid, but rather its net instead. So the surface area of a regular tetrahedron, could be greater than the surface area of a tetrahedron net. So for a tetrahedron, you simply just do the square root of 3a squared. But for a tetrahedron net, you have to do half BH times 4, because we're finding the areas of all the triangles, rather than the surface area of all the triangles combined using this formula. So, the surface area of the net is different than the surface area of the regular tetrahedron. So, yes, we could find the surface area of the net by simply doing half BH and multiplying that by 4. So 170 times 4. I would like to think of 170 times 4 as 340 times 2, because 170 plus itself is really 340. So if we add 340 and 340 together, we get 680 square centimeters. Would you look at that? Because if we find 2 of them, that makes 340, because we have to do half BH. 340 and another 340 there will make, 680 square centimeters. So, the surface area of a regular tetrahedron is greater than the surface area of its net. So, be careful over here. When you're trying to find the surface area of a pyramid in general, you just have to follow its formula. But if you want to find the surface area of its net, then you need to find the area of one of the face and multiply that face area by how many faces the solid shape has. So, in this case, it has 4 faces, so half BH times 4. That's it. But that's only for the surface area of the net. The surface area of a regular tetrahedron is the square root of 3a squared, so, which is 692.82. But in this case, the net is 680 square centimeters. It is approximate, but not close enough. So, yes. And you're probably wondering, how did we get this as our answer? Well, if we follow the formula correctly, the square root of 3 times 20 to the power of 2 is not the square root of 3 times 20 times 2. Be careful. This is the exponent. When you see an exponent here, you don't multiply 20 by 2. Instead, you multiply 20 2 times. So simply 20 times 20, that is 400, because there are 2 zeros, and 2 times 2 is 4. So 400, and then 400 times the square root of 3 would approximate to around 692.82032, which is very, very long. So, yes, the surface area, the difference between the surface area of the solid shape and its net could vary. Yes, but you're probably also wondering, how could I tell the tetrahedron and the triangular pyramid apart? Tetrahedron specifically implies that all the triangular faces are equilateral, meaning that all the sides of each triangle are equal. See, over here? But a triangular pyramid could have triangles of different side lengths on its faces. So essentially, a tetrahedron is a special type of triangular pyramid where all faces are congruent equilateral triangles or 3-sided shapes. So, yeah. So, not all triangular pyramids have equilateral faces. But surprisingly, that does not mean that not all triangular pyramids are tetrahedrons, because a tetrahedron could also be irregular, in which case it does not have equilateral or congruent faces. An irregular tetrahedron is also known as an oblique tetrahedron, because as you can see here, it is not congruent or parallel. So essentially it has no symmetries. So no matter what, you can't find any symmetries. Generally, though not necessarily, it has 4 different scalene triangles for faces. So see, all these triangles look completely different to you. That is an irregular tetrahedron. So yeah, surprisingly, all triangular pyramids are tetrahedrons, because tetrahedron would imply that it has 4 triangular faces that add up to make the pyramid. But not all of them are regular tetrahedrons. Be careful, a regular tetrahedron is a triangular pyramid where all the faces are equilateral. A triangular pyramid does not need to have equilateral triangles. So it could have isosceles or scalene triangles. If it has all 4 scalene, then it's an irregular tetrahedron. But all triangular pyramids are irregular tetrahedrons. But some triangular pyramids are regular tetrahedrons, or equilateral triangular pyramids. I know it's very difficult to understand, but it should be simple enough. So simply, the tetrahedron has no symmetries, the irregular tetrahedron, that is. But a regular tetrahedron does, because it has equilateral triangles. But a scalene triangle does not have a line of symmetry, because all of its faces are different. So an irregular tetrahedron is a tetrahedron with no symmetries. So, yeah, all tetrahedrons. Yeah, the tetrahedron is a very cool shape. So this means that all triangular pyramids are tetrahedrons, because let's look over here. It has 4 faces. Let's see. 4 vertices. And as we can see here, 5... No, wait. What does that read? I think it has 6 edges. Let's just see if we're correct. Let's see over here. A triangular pyramid has... Let's see how many edges it has. Yes, it has 6 edges. That number was very hard to read. I thought it was 5 for a second. So, it has 4 faces, 4 vertices, and 6 edges. That is a very cool shape. All of which, the faces are triangles. So, yes, all triangular pyramids are tetrahedrons, but not all of them could be regular tetrahedrons, because some triangular pyramids could have scalene triangles as their faces, in which case it is an irregular tetrahedron. But that's still a tetrahedron, right? So, all triangular pyramids are tetrahedrons, and surprisingly enough, the opposite is also true. All tetrahedrons are also triangular pyramids, because it looks like a pyramid, and it has triangular lateral faces. Triangular pyramids and tetrahedrons both have triangular lateral faces, which both naively define the definition of a pyramid. A pyramid must have triangular lateral faces. So guess what? All triangular pyramids are tetrahedrons, and all tetrahedrons are triangular pyramids. So, yeah, it's remarkable. It's a remarkable shape. Yes. But the surface area of an irregular tetrahedron is not as hard as you think it is. To find the surface area of an irregular tetrahedron, you simply calculate the area of each of its 4 triangular faces, and then sum them all together, or pretty much add them all together. So, in the case of the net, we would do that, but that is a regular tetrahedron net. So, the only time when we should calculate the area of each of its 4 triangular faces and then sum them all together is when we're trying to find the equilateral triangular pyramid net surface area, or when we are trying to find the surface area of an irregular tetrahedron. So that is the only time we use it. The surface area of a regular tetrahedron is the square root of 3a squared. So, yes. And again, an irregular tetrahedron is a tetrahedron with faces that are not all equilateral or congruent. So, yeah, triangular pyramids could be a very, very special shape. And, yeah, if you tell me, the surface area is very, very cool. So, yes, that's pretty much the surface area of a triangular pyramid. Now let's move on to the surface area of pyramids with 4-sided bases. With a 4-sided base. Like, for example, take a rectangular pyramid and a square pyramid, for example, which are all pyramids with a 4-sided base. This might be pretty complex to you, but it shouldn't be too simple. It shouldn't be too hard, because we have a simpler formula. But in case you want to know what the actual formula is, here it is. The surface area of a right square pyramid is a squared plus 2a times the square root of a squared divided by 4 plus h squared. Yeah, that's a lot of hard work, but it only requires two measures, the base edge A and the height H. So, let's look into this right square pyramid. We know it is a right square pyramid net because it has a right angle, and its base is a square, and it's flattened out like a pyramid net. So, we could conclude that this is a right square pyramid net. So, yeah. Let's substitute the base edge A and the height H. So let's first identify what A and H are. So A is the base edge. The base edge is one of the sides of the bases. This is the base, and this is one of the sides. Well, guys, all sides of a square have to be equal. So guess what? This is 20, which means that this also must be 20, and this must be 20, and this must be 20, and this must be 20. So all four are 20. So we can conclude that the base edge is 20. And then the height. Well, the height of the square pyramid typically applies to the height of the pyramid itself. However, we could make things less complicated by simply flattening out the square pyramid. In that case, then the height transitions from the pyramid overall to the lateral face, because the height cannot be examined three-dimensionally while still flat. So it has to move to the lateral face. So the height is 17 centimeters. Plus, if you look over here, this line appears the same as this line, right? They're all equal. So the height is 17 centimeters. So let's put 17 in. And for the right square pyramid overall, not its net, be careful, we should get a surface area of around 1,188.92. Wow, that's a lot. How do we do that? Well, using the formula that we applied here. Again, don't do 20 times 2. Do 20 times 20. That's 20 2 times. 20 times 20 is 400. And then 2 times 20 is 40. 400 plus 40 is 440. Then you multiply that by 400 divided by 4, which is 100, plus 17 squared, which is 289. And then 289 plus 100 is 389. And 440 times the square root of 389 is very complex, but it approximately leads up to around 1,188.92332. So, or simply just 1,188.92. But that is the surface area of the square pyramid overall. To find the surface area of its net, we need to find the area of one of the faces and add them all together. So find the area of all the faces and add them all together. This is only if you're trying to find the surface area of the net. The surface area of the square pyramid is much greater than the surface area of this net. So, yeah. But is it, though? Let's go find out. So, let's find the area of the square base. Remember how to find the area of a square? It's simple. It's one of its side lengths squared. So 20 times 20 is 400. So the area of the square is 400. And then the area of a triangle is half BH. So half times 17 times 20. Well, guys, we already looked at that at the tetrahedron net. So guess what? 17 times 20 is 340, and half of that is 170. And if we multiply 170 by 4, we should get 680, because 340 plus 340 is 680. But then there's the square base, which is 400. So we have to add 680 and 400 together. 1, 2, 3, 4. That leaves up with 1,080 square centimeters. So yeah, the surface areas are different because the surface area of the net only requires finding the area of all the faces and adding them all together. However, the surface area of the pyramid is different because it requires complex formulas. But don't worry, I will evaluate all the equations to you. You don't need to know this equation because finding the surface area of any pyramid is really simple. Instead of using these complex formulas to find the surface area of a pyramid, which is not its net, you could simply just do this. To find the surface area of any pyramid, calculate the area of the base B and then add the lateral surface area, which is half the product of the base perimeter, or P, and the slant height, L. So the surface area is basically B plus 1/2 times PL. So, yes, don't worry. There are a lot of complicated steps. Step 1, identify the base. If it's a square base, side times side. If it's a rectangular base, length times width. Triangular is half BH. Then calculate the lateral surface area, or the surface area of the lateral faces. Find the perimeter of the base. Add up the lengths of all of the sides of the base. This is the height of each triangular face from the base to the apex or top point of the pyramid. So, the point at which all the lateral faces meet at is called the apex. This is the tippy top of the pyramid, called the apex. This is the apex. So, fun fact, and then 1/2 times P times L is the lateral surface area. But then at the same time, you also have to find the area of the base. So you add the base, half PL plus B. It's very simple. Add the base area to the lateral surface area. Total surface area equals B plus 1/2 times PL. Let's do an example with a square pyramid. Let's say there's a square whose side length is 5 centimeters. Well, in this case, multiplying 5 by itself results in 25. The lateral surface area, the perimeter is 20, slant height is 6, and the lateral surface area, 1/2 times 20 times 6, is 60 because 20 times 6 is 120, and half of that is 60. And then the total surface area, adding up 25 plus 60, because remember, 25 is the area of the base, and 60 is the surface area of the lateral faces. And if we add two of these numbers together, we get 85 square centimeters. So, it's very simple. So, for any pyramid, just remember, for any pyramid, it's just B plus 1/2 times PL. That may require a little extra work and understanding and knowing about the slant height, but it should not be too hard. At least if you substitute numbers in, real numbers. So, yeah. So, all right. Then for a rectangular pyramid, whoa, I could tell you. This is a long and complex formula. The surface area of a right rectangular pyramid is LW plus L times the square root of W divided by 2 to the power of 2 plus H squared plus W times the square root of L divided by 2. This is L, not to be confused. L divided by 2 to the power of 2 plus H squared. Wow, that's a very long and complex formula. But don't worry. We don't need to know this formula. Instead, we could just experiment by substituting in the missing lengths. So, the length is how long it is. I think 16 centimeters is the length. Looks pretty long enough. This is the length of the base, so let's substitute 16 in. And then, the width is how wide it is. 10 is the width. So, let's put in 10 as the base width. And then, the pyramid height. Well, it is pretty difficult to know the pyramid height. And, to be honest, I don't know what it is. But we could find the slant height. The slant height is the height of one of the lateral faces of a triangular, of any pyramid. So, of one of the triangular lateral faces in a pyramid, the height of that face is the slant height. So the slant height only for these two triangles is 10, because this is a different triangle. This is 12, and this is 10. But we don't know the height of the pyramid, so we could simply just, I don't know, maybe substitute in a height as random. So, let's not substitute the actual height, and let's substitute a random height. Which height should we choose? I don't know, maybe 12. Let's substitute 12 as the height. So this is not the actual surface area, because the height of the pyramid is different. And because this is not the pyramid height, this is the slant height, or the height of one of the triangular lateral faces. But we could substitute the pyramid height for 12, because we don't know the height of the pyramid. So we could substitute the height for any number. If the base length is 16, the base width is 10, and the height of the pyramid is 12, then we get to a total surface area of around 512.22, or around 512.22205. So, yes. Want to know how he got it? Well, I'm not going to do the solving over here. But, in case you want to know, I'll solve a few. 16 times 10, 160, because 16 times 1 is 16, add the 0, that makes 160. So, 160 plus 16 equals 176, times 10 divided by 2, which is 5, then squared is 25, plus 144, which is 12 squared, equals 169. And the square root of 169 is 13, believe it or not. It's exactly 13. So 176 plus 13 is 189. Then we multiply 189 by 8 squared, which is 64, because 16 divided by 2 is 8. 64 plus 144. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, that's 208, but we don't know the exact square root of 208. So, let's do this. 160 plus 16 is 176. 176 plus 13 is 189, but then we need to add 10 to it, which makes 199 times the square root of 208, I guess. That approximates to around 512.22205. Yes. But if you want to find the surface area of the net, you simply have to find the areas of all the faces and add them all together. This is only for the surface area of the net, not the surface area of the pyramid. Because as we mentioned before, the surface area of any pyramid, which is not its own net, is B plus surface area of any pyramid, okay, here we go, is B plus 1/2 times PL. We could do the same thing here, but it would be a lot more complicated. So the surface area of any pyramid is B plus 1/2 times PL. But for the net, we need to find the area of all the faces and add them all together. So for the rectangular pyramid net, we're going to do things a little differently. So 16 times 10. 16 times 1 is 16. Add the 0. That makes 160. Then, area of triangles. Ready. So, 16 times 10 is 160. And half of that is 80, which means that this must be 80. Then, 10 times 12 is 120. Half of that is 60, because 60 plus 60 is 120. So let's review. 160, 16 times 10, then half of that is 80. 80 plus 80 is 160 over here. Then 10 times 12, 120. Half of that is 60, which makes 120 over here. Okay, so 160 over there plus 120 over there makes around 280 for all the triangles. Then we need to add 160 because that's the area of a rectangle. 280 plus 160 is 2, 3, 4, 5, 6. 440. So, yep. 512.22 is only the surface area of the rectangular pyramid when it is folded up into a 3D shape. However, 440 is the surface area of its net when it's in a flat shape. So, the surface area of the pyramid is different than the area of its net. So, be careful over here. But simply, again, the surface area of any pyramid is B plus 1/2 times PL. So, yeah. Next, we must look at a pentagonal pyramid. Whoa, whoa, whoa. Did you know how I said that the triangular prism has one of the most complex surface area formulas on the planet? Well, I am correct. But the pentagonal pyramid also has one of the most complex surface area formulas on the planet here. There is no definite most complex formula, so yeah. Don't worry, guys, you don't need to remember this. Remembering this would actually need to require some trigonometry, which we're not going to learn about. But if you see here, this is tan. We're not going to learn about tan. That's in trigonometry. And I'll tell you, trigonometry is so hard. It could actually be taught as early as 9th grade, perhaps, in Algebra 1, trigonometry. But don't worry, you won't reach there until you get into Algebra 1. That is years and years away, so don't worry. Sin and cos, which are the other mathematical signs, really stand for sine and cosine, which you will also learn in trigonometry. The laws of sine and cosine, we're not going to learn about those. No worries. This is way too complicated. We are way too early to learn about trigonometry. But if we look over here, the surface area of a right pentagonal pyramid is 5/4 times tan times 54 degrees times a squared plus 5 times a divided by 2 times the square root of h squared plus a times tan times 54 degrees divided by 2 to the power of 2. That is so complicated. I am not going to solve this formula for you, but we could substitute it. So, let's say that the base edge is 6. Let's say the height is 23. We should end up with a surface area of around 412.45, because if we look here, I was right. You multiply 5/4 and tan together, which makes 5/4 tan, but you don't need to know about that for a while. 6 times 6 is 36. 5 times 6 is 30 divided by 2 is 15. So this is 15 over here. Yes. And then 23 squared. I don't know what that is, but it approximates to around, once you substitute all the numbers in, it approximates to around 412.45283. But if it was flattened out into a net, you would have to find the area of the pentagon, and then find the area of the lateral faces, and then add all those areas together. But for the pyramid, it's simply B plus 1/2 times PL. We could do that here, but there are no specific measurements here. So, yeah, very simple enough. That's pretty much the surface area of any pyramid. So, except for the cone. The cone is pretty different. So, yeah, the surface area of a hexagonal pyramid is also very complicated. Don't worry, there is no tan, cos, or sin over here. In other words, there are no sine, cosine, or tan over here, or trigonometry concepts. We're not going to learn about trigonometry. Don't worry. Even I don't understand trigonometry. Trigonometry pretty much has to do with shapes, but could also be with algebra and simplifying radicals. See, like right here, this is a radical, but we're not going to learn about radicals. So don't worry. just saying that the surface area of any pyramid is b plus 1/2 times PL, but the actual surface area formula might get more complicated than that. So, but in case you want to know for this time only, the surface area of a right hexagonal pyramid is 3 times the square root of 3 divided by 2 times a squared plus 3a times the square root of h squared plus 3a squared divided by 4. So yes, let's say the base edge is 7 and the height is 90. We should get a total of around 2021.59. Hey, that kind of reminds me of the year 2021. Yeah, 1 year after the COVID-19 breaks out. That was a horrible pandemic. Anyways, over here, we could see this is very, very complicated. But in case you want to know, 3 times the square root of 3, I don't know what that is, but if we multiply them together and divide that by 2, we should get an answer. 7 times 7 is 49, plus 3 times 7 is 21. If we add 21 and 49 together, we should get 70. 70 exactly. 70 times all of this, and then times this, which I don't know. That will approximate to around 2021.58838. But again, if we flatten it out into a net, then we should not follow this formula because the surface area of the net is simpler. You simply just find the areas of all the faces and add them all together. But again, also for this one, we could also do B plus 1/2 times PL. But that's only for any pyramid, so yeah, this is a pyramid, right? So yeah, that counts. We don't have a particular surface area formula for heptagonal pyramids, but there is one formula right over here. The surface area of a heptagonal pyramid is calculated by adding the area of the heptagonal base to the area of the 7 triangular faces, using the formula SA equals 7/4 times A times B times C times pi divided... Wait, no, not C, sorry, cot. Yeah, I get confused. Okay, so the surface area formula is 7/4 times A times B times cot times pi divided by 7 plus 1/2 times 7 times A times S. Pi is a mathematical constant, approximately equal to 3.141592654. I don't know the other digits, but we're not going to learn more about pi until Unit 6, so no worries. Just saying here that the true surface area of true pyramids over here could be quite complicated. But, again, as we remember, the surface area of any pyramid is B plus 1/2 times PL. So, yeah, it could be as simple as that. And lastly, we have an octagonal pyramid with an 8-sided base. The surface area of an octagonal pyramid is different, calculated by adding the area of the octagonal base and the areas of the 8 triangular faces, using the formula SA equals 1/2 times apothem times perimeter plus 1/2 times perimeter times slant height. You probably don't know what apothem is. Don't worry, I don't know what apothem is too. The apothem is the perpendicular distance from the center of the octagon to the midpoint of one of its sides. So it's only for an octagon that the apothem is present. So 1/2 of the perpendicular distance from the center of the octagon to the midpoint of one of its sides times the perimeter plus 1/2 of the perimeter times the slant height. So, yeah, simply very cool. In this case, the slant height is the length of the line segment from the apex of the pyramid to the midpoint of one of the base's sides. So, in simpler terms, it is by following these steps. Yes. However, there is another way, an easier way. The surface area of an octagonal pyramid could also be found by adding the area of all the faces together. This is because the area of the base plus the area of the 8 triangle faces will give out the total surface area of the total shape. So, yes, this is an octagonal pyramid, a pyramid with an octagonal base. So, Yeah, very, very simple over here. Yes, but like I said, surface area of any pyramid is B plus 1/2 times PL, which you could also use over here. So, yeah. For its net, we could also add the area of all the faces together. And then there are two more kinds of pyramids, the enneagonal pyramid and the decagonal pyramid. The enneagonal pyramid is a pyramid with a 9-sided base, or a pyramid with a nonagonal base, or a pyramid whose shape is a nonagon, or a 9-sided polygon. So simply, an enneagonal pyramid is a pyramid with a 9-sided base. And then, a decagonal pyramid is a pyramid with one 10-sided base, or one decagon as its base. So simply, a decagonal pyramid is a pyramid with its base as a 10-sided shape. So, an enneagonal pyramid is a pyramid with one 9-sided base, and a decagonal pyramid is a pyramid with one 10-sided base. But you should always remember that there's a simpler formula. You either have two choices. Find the areas of all the faces and add them all together, or find the base and then add that by half of the perimeter and the slant height. So you have two choices. Number one, find the area of all the faces and add them all together, or simply just do B plus 1/2 times PL. Wow, that was a wild ride. That was a crazy, crazy wild ride. That was a lot of shapes. A lot of shapes, I could tell you. And a lot of shapes, that is. So, yeah, a lot of very cool shapes. Look at those fishies. I set that up as my wallpaper. I like fish. They're so cute. But I bet they don't understand the surface area. I bet they don't understand surface area at all. But we do, thanks to the formulas that we used. So, yeah, that's it from us today. I hope you enjoyed this cool video about how to find the surface area of any pyramid with 4 or more surfaces, because a tetrahedron has 4 surfaces, or 4 triangular bases, which serve as 4 surfaces. A cone, which is a special kind of pyramid with a circular base and a bent lateral face, only has 2 surfaces. But we're not going to learn about that until Unit 6. So, don't worry, guys. We will learn how to find the surface area of a cone later. Or, simply, a cone or a type of pyramid with 2 surfaces is a pyramid. A type of cone, a type of pyramid, with 4 surfaces is known as a tetrahedron. So, yeah. I bet the fish don't understand. Some fish are smart, though. They could really solve problems. That's it from us today. I hope you enjoyed a lot about pyramids and a new shape name that we just learned. The tetrahedron. The tetrahedron. I don't think the fish understand what a tetrahedron is. And in case you want to learn more about how to find the surface area of a tetrahedron, you could always go on YouTube and watch some cool and informational videos about the surface area of such a shape, and it will tell you the exact formulas. I know that this was not very precise because I did not solve most of the actual formulas because they are way too complicated, but they are precise geometrically and mathematically. So, yeah. Mathematically speaking, the answers are correct. So, sorry, fishies. Shut off. Okay, anyways, that's it from us today. Surface area of any pyramid. Bye, everyone. Bye, everybody.